billion light years from where you're sitting right now. There's a hole in the universe so massive that it doesn't just bend space around it. It might be the biggest thing of its kind that will ever exist, not the biggest we've found. Its name is Phoenix, a star, and by the time this video is over, you're going to understand why scientists look at this object and start using words like impossible. Let's get into it. To understand Phoenix, a star, you first have to understand the neighborhood it lives in, because this thing didn't grow up in a normal part of the universe. At the center of the constellation, Phoenix sits something astronomers call the Phoenix Cluster, officially SPT-CLJ2344-4243, if you want to sound smart at a dinner party. A galaxy cluster isn't just one galaxy, it's a city of galaxies, sometimes over 1,000 of them, all bound together by gravity into one enormous structure. And the Phoenix Cluster isn't just any city. It's one of the most massive, most luminous galaxy clusters humanity has ever pointed a telescope at. Here's the part that made astronomers sit up in their chairs. This cluster is forming new stars at a rate of about 500 to 800 suns per year. For comparison, our entire Milky Way, a fully grown, mature galaxy, produces maybe 1 or 2 stars a year. The Phoenix Cluster is basically a stellar nursery on cosmic steroids, and at its heart sits a single monster galaxy, cleverly named Phoenix A, that is swallowing gas, crushing it into stars, and feeding something even hungrier at its very center. That something is Phoenix A star. Here's where you need to sit with a number for a second, because your brain is not built to process it. Phoenix A star has an estimated mass of up to 100 billion times the mass of our sun. Not 100 billion kilograms, not 100 billion Earths, 100 billion suns, each one over 1 million kilometers across, each one containing more mass than every planet in our solar system combined. And Phoenix, a star, outweighs 100 billion of them. For context, our own galaxy's black hole, Sagittarius A star, clocks in at around 4 million solar masses. Respectable, terrifying even if you're a star that wanders too close. But Phoenix A star isn't just bigger than Sagittarius A star. It's roughly 25,000 times bigger. If Sagittarius A star is a golf ball, Phoenix A star is a sphere you could roll down a football field. And here's the detail that really breaks your brain. Some estimates put the mass of this single object as being greater than the combined mass of every star in an entire galaxy. 1 point. One infinitely dense point in space, heavier than a galaxy. Now you might be thinking, okay, it's heavy, but a black hole is basically a point, right? No real size to speak of? Not exactly. Every black hole has what's called an event horizon, the boundary around it past which nothing, not light, not information, not physics as we understand it, can escape. And the more mass a black hole has, the bigger that boundary gets. For Phoenix A star, that event horizon is estimated to stretch across roughly 590 billion kilometers. To put that in units that means something, the average distance between the Sun and Pluto is about 5.9 billion kilometers. That means the event horizon of Phoenix A star is about 100 times wider than our entire solar system, measured out to Pluto's orbit. Let that sink in. If you swapped our sun for Phoenix, a star, its event horizon alone, just the boundary of no return, would swallow Pluto, and then keep going for another 100 solar systems worth of empty space. If you tried to fly around the this thing. For years, the title of most massive black hole known bounced between a few contenders. There's TON 618, a blazing quasar once estimated at 66 billion solar masses, though more recent measurements have revised that number down to around 40 billion. There have been other candidates that seem to briefly take the crown, only to get demoted once astronomers refined their data and realized the mass had been overestimated. But Phoenix A star has held its position near or at the very top of that list. And what makes it even stranger is a theory published by Yale astrophysicist Priyamvada Natarajan and her colleagues, who modeled how black holes grow over cosmic time. There may be a hard ceiling on how massive a black hole can ever get, somewhere around 100 billion solar masses. Why would there be a limit? Because of feedback. As a black hole feeds, it doesn't just quietly absorb matter. It heats the gas falling toward it to millions of degrees, blasts out radiation, and fires off jets of particles at nearly the speed of light. See, eventually, the black hole starts cooking its own food supply, pushing away or superheating the very gas it needs to keep growing. It becomes, in a sense, a victim of its own appetite. If Natarajan's model holds up, Phoenix A star isn't just the biggest black hole we've discovered. It might be sitting almost exactly at the theoretical maximum size any black hole in our universe can ever reach. Not the biggest we've found yet, possibly the biggest that can exist, period. Here's the part that makes Phoenix A star even more fascinating than just big number goes here. This black hole isn't sitting quietly. It's active, ferociously active. As matter spirals toward the event horizon, it doesn't fall in smoothly. It superheats, compresses, and screams out energy in the form of radiation and jets blasting outward at velocities close to the speed of light. Those jets are powerful enough to punch massive cavities into the hot gas surrounding the galaxy cluster, carving out bubbles bigger than entire galaxies and heating the surrounding material to tens of millions of degrees. And yet, bizarrely, this same violent process seems to be connected to the explosive star formation happening in the galaxy around it. Somehow, in this cluster, the black hole's outbursts and the surrounding gas cooling down to form stars are happening at the same time, in a delicate and still not fully understood cosmic balancing act. It's chaos and creation running on the exact same engine. It's easy to hear a number like 100 billion solar masses and let it wash over you as just another crazy space fact. But step back for a second. This is a single object, born from the collapse and slow accumulation of matter over billions of years, that has grown to outweigh entire galaxies. It sits at a boundary condition of physics itself, possibly the largest black hole the laws of nature will ever allow to exist, anywhere, at any time. We're talking about an object so extreme that light itself needs over 2 months just to trace its outline. And it's sitting out there right now, 5.7 billion light years away, quietly rewriting what we thought was possible. The universe didn't just build a big black hole. It may have built the biggest one it's capable of building at all. If this blew your mind, you know what to do. Hit subscribe, because we're going even deeper into the strangest objects in the cosmos. And trust me, this is just the beginning.